So we'll talk about the course certification. We'll first start with the CCI portion, CCI or CCNP security portion. CCI consists of two mandatory papers. One is Score and second is the CCI lab, which is 8 hours. Okay, and this is divided into 3 hours, which is design topic, and then 5 hours. Whereas for CCNP security, you have to write this core paper, which is a MCQ pattern. Thus remains same for CCI as well. It's a MCQ pattern. And then you have 7 to 8 concentration paper. It could be ASA FTD, it could be Cisco ICE, it could be one topic from automation, it could be Cisco ESA or WSA. So you can select from the concentration paper. Okay, one of them is ASA or FTD. This is what we are picking up now. We will start with this, right? Apart from this, you have ICE, you have ESA, email security appliance, you have web security appliance, you have one topic from automation. So these are like all or scenario. You can pick any one to be classified yourself as a CCNP professional. So this is the mandatory paper, and then you can select one of them. The same thing will help you later on for CCI security. You don't need to write any other paper. It's the same paper. But this is something which is a scenario based. It's a practical. All right. So this is for CCNP. And coming to the firewall mastery, which consists of all this vendor based, you will have a vendor based certificate for that. So we are covering this from the CCNP concentration level, which I just put down some time back. Palo Alto, we are covering PC NSA, PC NSC. The exams, you can book it from the Pearson website. It will be a OEM vendor specific exam. For FortiGate, we are covering NSC 4. For FI LTM, we are covering 101 and LTM administration. For checkpoint, we are covering CCSA. CCSA or we will see if the demand is more for Sophos, then we'll go with Sophos. So this is like optional. Whatever we decide, we will go with this. Okay. So as of now, we have selected checkpoint, but if the trend differs, the trend says that checkpoint is not something usable nowadays, then we can go with something which is better, like Sophos or something. So this is how the course outline looked like. The exam booking is all done on the Pearson website. You have the account with them. Whatever exam you are preparing, whatever exams that you want to write, you will do it on the Pearson website, except this particular exam. This exam you cannot do it on the Pearson website. This you have to book it only on the Cisco website. There is a dedicated website for Cisco lab. So you have to select which, because this is in person, whereas rest all can be done either in person or virtual. In person, in the sense you want, you can visit the Pearson Center and then write, or you can do it from your home as well. So this option is available now on most of the exams. Something like this. Whereas for CCI lab, there is no option yet for virtual lab. You can decide BYOD, or there is something called a mobility centers. That means, say for example, if I'm just giving an example, if you're from Egypt, you guys will not have a valid Cisco's center, because see, this is this in person, in the sense a person has to visit, right? He will be visiting the Cisco office, so they may not have a Cisco lab, Cisco CCI lab in Egypt. So in that case, they can book it from anything which is nearby. Like Saudi is very close enough for them. Riyadh, Saudi, they can visit one of the office. They can bring their own laptop, but they have to make sure laptop will clear the feasible test. Then only they can carry this. Mobility center, in the sense, they will charge bit more. Like they can charge you 400 more, but they will provide you all the laptops and all those things. So you can visit, you can write the exam, and you can come back. Otherwise, in case if this is not something you want to go, then for you, the nearest one would be Dubai. Dubai is like from Egypt, like 6, 7 hours. Then the stay is needed, another expenses. But if you prefer going with BYOD or mobility center, and you pick up like Saudi or whichever is nearby, which is just a drive away, 2, 3 hours. So you can save on the stay. You can save on the air expenses. So that is up to you. But Cisco has come up with this option as well, BYOD and mobility center. This will cost you a bit more. The reason is they will give you the needful hardware. With this, it is 1,500 or 1,400. But the problem is, on the exam day, if your laptop get any technical issue, they are not liable for any compensation or any reissuing of any vouchers or something. So you will be risking your own exam by just to save 200 or 300. Whereas in person, a regular guy, like if you're from India, you can visit Bangalore. There is a CCI lab for that. So it will be costing you something around 1,500 USD. Using your Visa card, it might get convert as per the conversion rate of that particular day. Okay, and rest of the exams, the score and all those things, they can vary. They will be usually like 450 USD something. This would be something like 350 to 400. 400. Let's say this would be, okay. This is score, right? So 450. This will be somewhere 400. Concentration paper can be little less expensive. You can just consider that the actual price you have to check on the website. They can change anytime. So let's say this would be like 250. PCNSA could be 250, whereas PCNSA could be like 350 to 400. FortiGate 250. FI LTM could be 150 to 250. Checkpoint also like 150 to 250. So this is how the costing is happening. So either you can book it. Where do you book your exam? You book it either on the Pearson website, and for CCI Lab, you have a dedicated portal on the Cisco website itself. Okay. So Pearson website for all other Cisco CCNP exam or Palo exam, FI exam, FortiGate exam, everything on Pearson. And you need to see where do they have a nearby center. In case if you want to go in person and write, you can definitely go in person to the Pearson center. Okay. Nothing to do with the vendor or nothing to do with Cisco location now. It is from Pearson website. There would be lot of institute who would be tied up with Pearson, and they let you to come in and use their infrastructure to get it done. Otherwise, if you have a good laptop, good internet, you can do it virtually from home as well, except this CCI thing, okay, which is only in person. So you can either visit the Cisco office if you have a center, or you can have BYOD and mobility center. So where do you get all this information? You can just look at this website, Cisco CCI exam booking location. So they will display all the centers that's nearby. So these are the mobile lab location. Okay. So for example, if you're from Egypt, then you have options like Saudi Arabia, Riyadh, which is very nearby when compared to the other option of going to Dubai or something. Similar way for India, if you are from, let's say, do we have anything for India? No, for India, there is only one permanent location, which is in Bangalore. There is no mobile location, at least in India. So if you are from Delhi, Kolkata, or any Jammu, Kashmir, you have to visit Bangalore in person to write this exam. Okay, so the details are all on the website. You first have to go through. I'll just give you this link. You can keep it with you handy in case anytime you need it. And for the regular exam, Pearson is where you have to book it for CCNP, Palo Alto, F5. So you go, you register yourself. There is a test center. So this is a different entity, nothing to do with any vendors. I'm looking for Pearson with Cisco exam. That's why the logo of Cisco. Similar way, when you look for search for Pearson with any other vendor, Palo Alto, then they will display that particular vendor logo here. So in case if I look for Bangalore, see, these are the options that I have. I can book the exam from any of the center, go there and write my exam. But from last 2 3 years, when the Cisco introduced virtual, I never went and did this, in person. I just book my exam and just do it from home itself, which is more convenient. So they will have their own checks and own things to verify whether the student is sitting alone, if he's surrounded with a proper environment, or he has some other monitors or other digital gadget, then they will ask you to shut them out, or they will ask you to move into another room where you are, having the protocols followed for virtual exams. All right, so we will move further. This was from the exam point of view. Since we have three different uh, courses, so I just explain all of them in general. Coming to the lab access from our side, especially for Cisco ASA FTD, I'll give you two labs. One is the ready-made lab, which is like a massive lab. You can do a lot of things on that. And then I'll also give you empty lab. That means you can build your own. Okay, some people might be starting now. They may not get whatever is on the ready-made lab. So you guys can start with a small lab first, and then you can practice this. So for this, the workbook I would be giving you, step-by-step workbook I would be giving you. For empty lab, it's your choice. You will be replicating your environment, or you would be building a small lab from wherever sources. So you can come up with your own configurations for this. And you need any help, I can help you with that. And the same thing go with all of our module when we do CCNP score, or when we do F5, we do anything, it will be the same format. So I am not writing it because we have so many things. So it will be just a lot of things. I can just put up here any other courses with us. It remains the same. The pattern will remain the same. So just to show you the ready-made lab, let me log into the lab environment first. I'll just log into my lab environment and I'll show you how does it look like. So this is the lab environment for ASA FTD and bit of automation that we need from the exam point of view. I believe those guys who have enrolled, you have already received these, right? This lab. Can you just confirm me if you received this lab or not? Because we have rolled out 2 weeks back itself.
Yeah, we received the email.
Okay, okay. Might be you may not have tested because you might be waiting for me that I'll show in the day one, right? But did you
Yes,
check your
yes.
login and all those things?
No, not yet.
Okay, no issues. So this is the lab which we have given to all the enrolled participant. So those who have not enrolled, you will get it once you enroll to the course. Okay. All right. So how do you access them? See, these are all individual nodes here. Individual nodes here. There can be a Cisco firewalls, it could be a router, it could be a switch, it could be a DHCP server, it could be the test win PC. So lot of nodes are kept. Now, someone who is just starting with security domain, he might get confused. What is going on? What is what here, right? So do not worry. I will be giving you a very small lab in the beginning. Might be, a empty space or something. So you can make your own lab also on a daily basis. What we discuss, it don't need the entire big setup, right? You can just do your own small lab as well. So you can add ASA, you can add let's Win PC for if you want to test something very importantly, you can do that. You can add any router of your choice. So let's say I add one router here from the list, and you have this. You lay your cable from your understanding for that particular class, whatever you learn, do your own self studies, and you should be able to power on. You can just select them, power them on, right? It's very simple to build a small lab as well. Those who are guys are having some touch, you guys, in case uh, want to use the massive lab, you feel free to use the massive lab itself. But for someone who was into routing switching and are now trying to get into the security domain, you go by bit and pieces. I'm giving you both the option. It's your choice what you want to prefer. And how do you open this console? Just double click. When you double click, the console will open. Okay, so you have something you have over here. The ASA is booting up. You have Windows PC booting up. So it's very simple enough. Okay, what next? So this is lab access from network journey, which I would call it as remote lab, just for the reference purpose, because I will also be giving you a home lab setup. But make sure you have at least more than 24 GB RAM with with let's say at least a 4-core CPU on your laptop with at least a 100 GB SSD is better, preferable. But if you have a normal hard disk, that should be also fine, but it will be little laggy. Okay, like you write something and that take place after 10-20 second of delay, which is not always preferable to do such labs. But I will be giving you a home lab setup, which is usually a OVA file. My backend team will take your screen sharing over on Ultra Weaver or TeamViewer, and they will deploy this on your machine. So you will have both the access, you will have this access, plus you will have this access. So whatever is feasible, you can use that. If you think remote lab is not very convenient, because see, this is convenient. We are giving it 24/7 bar and for next 2 to 3 months for a module basis. Uh, so it is convenient, but still, if some people say that even after that, I would like to have my own lab, so we are giving you the whole ready-made file as well. So usually this from my side will be like a file of 30 to 50 GB, because it will have so much of image inside them. The files will be needed, right? So it will be 30 to 50 GB given in a Google Drive link or Mega link. You can download, and you should have this much in your laptop to accumulate the file which I am giving. And then you can have your own home lab setup as well. All right. So this is from the lab access. Yes, if you have already your own platform, we will give you the image itself. You can copy them in the backend using WinSCP or something. and you can utilize it. Okay, now coming to what? Coming to next topic. Let's say Cisco ASA. Cisco ASA firepower. We'll start with ASA today, and might be tomorrow we can see some firepower onboarding things. Though ASA is end of life, but in the exam you will expect questions asked from ASA. So version 6.0 had question based on ASA covering scenarios like remote access VPNs. You had a scenario asked from the cluster context and one of the VPN as well. So these questions were asked from ASA, even though ASA is end of life officially from Cisco, but a lot of organization in Middle East are still using ASA. Okay, so ASA is still being used highly and widely. So we cannot skip this and straight away start with firepower, even though firepower is considered one of the next gen firewall. The roots are always starting from ASA. So we'll start with ASA. We will have some sessions for ASA and then we can get into the firepower. So whole Cisco ASA firepower will take almost like might be 1.5 to 2 months from the delivery point of view. And then you will have your own time for labbing and scenario, because we are giving you the remote lab access for what, 3 months something, right? So you will have at least a month or more where you can have your own time for testing out the workbooks. Workbook for ASA, workbook for firepower. So we are good. Any questions so far before I get started with something concept based? Are we good?
So, yeah, Vishnu here.
Yeah,
Can
yeah,
I talk?
yes.
So, I mean, so the mastery course will be included with Cisco as well, the Cisco ASA.
Exactly. The mastery has one module which is covering ASA Cisco product. This one.
Okay. And by when this the mastery course will be completed? Like, by,
You mean the total duration for mastery?
yes.
It is around 3 to 4 months. I
Okay,
can
the
just
whole
say that,
course.
yeah, I can say 4 to 5 months for to be in a better situation. This CCI
Mhm.
security is almost like 5 to 7 months, since we are taking it only on weekends. And firewall mastery, as I told you, it will be 4 to 5 months, and CCNP security would be 3 to 4 months.
Okay, thank you.
You have a way to cut down few months. In case if we launch a parallel module, then you can take two at a time. So that way
Okay,
you can shorten up your whole duration. In case if you are planning to complete early. If not, you want to go with one after one, then this will be something you have to follow. Any other question, guys?
What about I? Do you cover some?
Come again. Sorry, come again.
I was asking about ICE. It is
Yeah.
also frequently used, right? So, are you still covering ICE some part on the CCIT security?
Yeah, in CCI security, in the CCI security portion, ICE is a complete module that we have it. So CCI security here consists of lot of modules. So I have written score here. Similar way, we will have a dedicated module for SVPN. We will have a dedicated module for Cisco ICE. We will have ASA FTD. We will have this ESA WSA, and then finally the CCI security bootcamp. So this is what is covered in this 5 to 7 month. So ICE itself is a dedicated module of two month, 2 or 3 month.
Got it. Thank you.
So that's mean this course will gonna take more than 1 year,
Which course?
like the whole CCIE security.
CCI security is 5 to 7 month. I've kept here. Okay.
So we will be covering all these modules, right? All the
Exactly.
concentration modules.
Not all of them, not all of them. The automation and ESA, WSA will be combined.
Okay.
Okay. So it will be like 4 to 5 modules that we will be covering. So this is one,
Okay.
2, 3, 4, 5, 6. Total 6 module it will be.
And for CCNP, we can give any one of the concentration as well.
Yeah, exactly. You can give any one from the list.
Okay. Okay. Thank you.
For the CCNP, so the concentration wouldn't be just MCQ, right?
It will be MCQ itself. There is no troubleshooting even in the concentration. It will be MCQ paper itself.
Oh, so it wouldn't be like a lab
No, there is no
kind of
lab.
thing?
It will be in-depth topic, however, but it's a MCQ format itself.
Got it. Okay. So for Palo Alto, PCNSC, did you already started parallelly, or I mean, is it ongoing?
No, not yet. It is not yet started. We will start next month parallel.
Okay, so after the ASFTD.
Not
Is it after the
exactly,
ASFTD?
not exactly after ASA, but somewhere like when this is 50% completed or 60% completed, we will announce about this.
Got it.
Okay.
Thank you. Yeah.
Hi, Sagar.
Yeah, hi.
Hi.
Hi, please.
So I have a doubt. Actually, I'm from routing and switching background. So actually, in CCIE, you will be covering from the basic now security here.
Exactly. Yeah, exactly. That is why I said ASA FTD is one of the simplest topic to get started. So we will
Okay.
start this module and
Okay. You will
we'll
be
go. Yeah.
got it. You will be covering the basic terms of the security also, no?
Yes,
Everything
yes.
from
Yes,
the
yes,
basic.
exactly. Yeah.
Yeah. Otherwise, we should have to go through anything.
No, the prerequisite is if you are from CCNA background, that is a prerequisite.
Okay. Got it.
So we will be having our admission counselor joining after my class session today. So any question related to the pricing or something, you can discuss with him. Okay. So we will keep that for later stage. Right now, we will discuss only the technical topic and anything related to technical exams or lab or something. You feel free to ask me because I saw some people asking in the Zoom chat. So just wait for the session from my side to end, and then the next person who would be taking over from me, you can ask any question related to any lab duration, remote access, or any thing related to backend things, or the pricing, discount, whatever you want. You can ask the other person. He will be the right person who will be discussing about that. Okay. All right. So we will go with some topics. So as usual, if you know, the firewalls act pretty much different than a regular routers or switches, right? So what is the difference? So do you guys have any idea about what's the difference between a regular firewalls or a router or a switches? See, we have some network components, right? Routers, let's say switches, and when compared to firewalls. So what happens in a router? What happens in a firewalls? So this is what we will check today. So do you guys want to pitch in and put some pointers so I can write it? What do you think router does and firewall doesn't? What do you think a router can do and a firewall cannot?
So router will gonna see in the routing table and switch the packet to the direct IP address, and switch will gonna see the ARP table and then switch the packet to that particular MAC address.
Okay. So what happens in a router? The decisions are based on the routing table, right? So what about in the firewall scenario? How do you think what happens in a firewall?
It looks
Decisions
for
are made
source
on
and
the base
destination.
on the rules.
Okay. So rules comes first or routing comes first?
Firewall is
Routing
packet
comes
inspection in the network.
Sorry?
Firewall is a policy that he can inspection of the packet from outside and inside network.
Okay, so what comes first? You say rules comes first or routing table will be considered first
The
for
routing
firewall.
table.
routing table
For the
will come first because that's how traffic is forwarded.
I'm talking from firewall point of view.
Routing table first, then rules.
ideally
I
rules,
think rules.
Rules
I mean,
will come first.
based on rules and policies, right? That's how it will filter and
Yes, so this is coming first. If it is deny, then your firewall is not even going to spend a 0.001% utilization just to look after what is routing enabled or not routing not enabled. So rules and policy will be first checked. If it is good, then comes the routing things look up. If route is not available, then it will drop it at certain point. But if the policy itself is denying, then there is no reason for firewall to entertain that packet inside for all this checkup of NAT table, route table, or QoS table, L2 lookup. It is no need of anything in that scenario. Alekya, you have some question? You just unmuted.
Sorry, my bad.
Okay.
I
Puneet, you
don't
got
have a
any
question.
question?
Yeah. So on the firewall, when traffic any packet enters, does it check first the net policy or the firewall policy?
That is again different steps there. Okay. So NAT will be first checked, then comes your ACL, because sometimes what happened, there will be a NAT translation and untranslation. So the actual IPs will be hidden, right? So first the translation will be checked and then it will check with the ACL rule. We'll talk about that in some time.
Okay.
So if we say that the routing is going to be consulted, if policies and rules are going to be consulted first, how the traffic arrives at the firewall in the first place. I think it looks into the firewall in the routing table, see where the traffic is going, and then based on that source and destination, it makes the decision not to allow or to allow the traffic.
See, how it arrives to firewall is not decided by firewall. It is decided by the guy who was connected to it. So the routing table of this router is checked to send a packet here. Now, when the packet arrives to firewall, firewall is not first going to check whether I have a route to send it out. It is first going to check the needful thing, ACL or NAT policy. So basically, policy will be checked. If the policy say no, deny, it is denying without even looking for a route or something. But if the thing says permit, if it says that permit, then comes the routing, then it will send to whatever it has to send it.
Okay.
Okay. Okay, what else?
Can you
What else do you think difference between router and firewalls? Anyone from oversight layer? You guys know
Yes,
what is yeah,
router has usually different kinds of layer 1, layer 2 connections.
okay.
For one
mean-
connections, for example.
Okay, so in which layer is router kept?
3.
Okay, layer 3, and if it is a switch, we can say that layer 2,
2.
or a switch can also work in layer 3. Exactly. But what happens in firewall?
It can work on layer 3, 4, 5, up to 7.
Next generation firewalls work until the layer 7 as well.
Okay, what about ASA?
ASA layer 4.
Layer 4, 3 and 4.
You can say layer 3 and 4. Okay. And the other guys, like the next gen firewall, they will do from all the layer perspective. Okay. Layer 1 till 7, you can just add it. Okay, what else do you want to include? Is there any by default any implicit?
Firewall has an implicit deny by
Okay.
default. All
In
the traffic will be dropped.
In which scenario? Implicit deny?
By default in firewall.
Interzone.
No, I mean
Firewall.
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 Okay. Implicit deny on the firewall. Whereas here there is no such deny, but you can add it with the help of what? Dash, dash, dash.
ACL.
Yes, you can add based on ACL, but this is optional. Optional in the sense, if in case you need it, otherwise it's all permit. They only check the route table and they will push it. They will route it. But if you think that why this is happening, you can block it by adding a ACL with deny statement. But in the case of firewall, this is by default. You take a firewall, let's say you purchase a firewall today from Cisco, go and plug it in your network. Your network will isolate in two pieces because firewall by default is going to divide them or block all the packets. Whereas if you do a router, you just put some IP address and just, put it in a network, it will start seeing how to reach the destination. If it will have some default gateway, then also it will push it to the next person via the static route or default gateway. It will push it, but it will never deny it or it will never drop it. The drop only will happen in router if it don't have that default gateway or static route to go to the next person. It will drop it. But in the case of firewall, it will drop because both the zones, say for example, if this is a firewall and if I have some interface which I've cabled with some other network devices, so these are actually by default denying it. It's called implicit deny. And to allow this, you have to come up with a permit ACLs. Okay, you have to come up with permit ACL. Here you will see both type of ACL, standard and extended. Whereas in firewalls, you will see extended ACLs because source and destination are both equally important. Okay, what else? What else do you think a router versus firewalls?
Can you hear me?
Yeah, sure. Yes.
Yes, routers usually have different layer 1 connections like LTE connection, serial interfaces, and firewalls don't have that.
Okay, from the physical appearance you're saying. Okay, yes. And what about in the firewalls?
You typically only have Ethernet connections.
Okay, so let's say serial interface, any other sort of physical interfaces. So here most of them are having a Giga Ethernet at least. Okay, Giga Ethernet interfaces. Whereas the next gen firewalls, you can see like 10 Giga Ethernet or something which is capable of 1 gigabits per second throughput. Okay. What else?
See, Sagar, in the firewall, having also fiber port also is the requirement for the uplink.
Yes, exactly. Fiber port is there in all of them. Okay. So here you can see fiber port.
And that is the network modules. We can hot swappable removal is there.
Yes. So you have the SFP concept. So you also have some SFP concept here. But again, not all firewalls will have a hot swappable concept. There are some
Only for based on only for the based on the entry models.
Yeah.
Like a ASA 5504 55 series.
Yeah, that is why I have not put that as a difference, because that's a common symptoms for both. Even in a router, you will see some device, some basic entry level which is non-hot swappable, where the interface when the device don't have a fiber port. Yeah, the higher you go, you will find fibers. You will see the 10 giga Ethernet. You will see hot swappable, dual chassis, soup engines, etc., etc. Same goes in the firewalls also. The basic entry will not have the hot swappable. You will have a single chassis. You will have a basic router type of devices. When you move up, you will find chassis, dual engines. You will see hot swappable. The units would be hot swappable. So hardware perspective, they have some similarity. Some are entry levels, non-hot swappable. Some of them which are high end, they would be hot swappable.
Yes, sir.
As a state table.
Come
Because
again?
why I'm telling here, I was work multiples. That's why I'm update share the information.
Okay, sure, yeah. Sorry, I could not understand. Someone was telling some point. I could not get it.
I mean, firewall as a state table.
Connection table, you mean?
Whereas a router doesn't have.
Okay,
Yes,
yeah.
Yes, connection table. Right.
Yeah. So there is a concept of connection table here, because it's going to keep a record or monitor all the in and out connections. Whereas router don't keep such records. All the connections are happening in real time over on control planes with the help of routing table. But in the case of firewalls, to avoid any excessive writing of bidirectional rules or reply packet, we can go with a connection table. So basically what connection table is, let's say if this is a firewall, any firewall, ASA or Palo or any one. So when a connection has started, okay, they will maintain a table called connection table. So when the return traffic is coming back for the same source, destination, and port number, you don't need another rule to justify or permit it. It will see the connection table. Connection table is existing for that connection which was originated, and it will just come back without any additional rule. So that concept is only in the firewalls, not in the router. So that is why we have put that as one of the diff maker point difference.
So what will happen if there is asymmetric route?
If you have asymmetric route, packet will drop. So you should make sure that there is no asymmetric connection happening. It will be treated as a new connection then. Asymmetric is happening.
Okay.
Because the source and destination will differ now, right? So it will be treated as a new connection. And for that, if you have a permit statement, then it will allow. Otherwise, you will lose your traffic. Okay.
Maybe the strong point of firewall, most of them, the appliance we can configure as a cluster devices.
Sorry, come again.
Yes, we can configure firewall for high availability clustering.
Exactly. High availability. You mean to say high availability?
Yeah.
Yeah, exactly. High availability. What about in routers? How about
Routers have
No,
similar
router doesn't.
services like HSRP, GLPP, VRP.
Exactly. So you can use one of them. Also, if it is from the dual ISP, then you can bring this IPSLA and all this concept, which you can also have in the case of firewalls also. Firewalls like Palo Alto, if you remember in my last demo class, I had given you a dual redundancy example. We did one lab for Palo Alto. So those are like similarities. High availability is in every technology. Firewalls, routers, switches, SD-WAN, ACI, you need to have high availability. So it's like a common point for both of them, but from a different methodology. This will make use of some different protocol, whereas firewalls will have their own way to deal with that. Okay, what next?
Separate
Routers.
context.
Sorry, I missed it.
Separate context we can create as like different hardwares in firewalls, like
There's
ASA.
there's a VRF too. There's a
Okay.
VRF in router.
Yeah, that
Okay.
would be the same
So
concept as VRF.
router will not do that?
VRF.
Yes. So something similar to VRF, I can say for context in firewalls and in router VRF. The purpose of context is to divide a physical unit in multiple section. So each customer can have their own routing tables, own piece of hardware, RAM, CPU, etc., dedicated for them. Whereas VRF is also similar way where you divide a whole routing table into a smaller portions. So not exactly same, but almost the same purpose. Okay, what else?
Routers do typically aggregate services like telephony, DNS, NTP, and firewalls usually don't have these features.
License subscription.
Okay, 1 second. Just a minute.
License subscription and routing table capability.
Okay, first I think Chris was telling something. I missed that.
So routers typically are a point of service aggregation, like for telephony, DNS, NTP.
Okay. But that we can have on firewalls also, right? Okay, my question is, can we have firewall as your edge router? Edge router in
Yes,
the
it
sense,
is possible. It is
can
possible.
I use it to connect to my ISP and do all the other things like NAT, routing,
Yes,
and I enable
then you can do
OSPF,
BGP.
BGP. So in that case, it will act as a regular router itself, right?
Yes.
Yeah. So that you can do it on the firewalls in case if you want firewall to treat it as a regular router, then that's doable. So you can have firewall acting as edge router. So at that point, it can support DNS, it can act as DHCP, it can act as NAT device. Okay, multiple services you can enable, including routing table, routing protocol. It supports BGP, OSPF on a LAN side. So all this you can do in a scenario where you're dealing with a small to intermediate enterprises. For a large enterprise, we try to segregate. We keep a router for all these purposes, and firewall will be more like packet inspection, anti-malware, or filtering of packets. will the routers do any packet inspection? For example, if this is a router, if a packet just entered, is it going to, for any reason, open up the packet and see if it is uh, packet with, let's say, image format, or it's a packet with a movie format, or it's a packet with some PDF? Will a router would be doing that?
No.
Yeah. So packet
No.
inspection is not done. Okay, not done by routers. They at the most, if applied ACL, will only check from the layer 3 or layer 4 point only. They will never see the layer 7 or anything to deal with packet inspection. Whereas in the firewalls, they have a concept of DPI, deep packet inspection. So with this, they have the capability to inspect every packet, open them up, see the content or context of that packet. In case if they are a recognized one, they can take the action. If they are not recognized or it's a unknown type, they have a capacity to talk to their Talos. Okay, something which is a cloud. So they will contact the cloud. They will see what is the origin of this packet. Is it a white hat or a blacklisted thing? And it can do the needful thing. If we that depends on us what we are going to define. Can I allow a unknown packet, or can I block a unknown if I get a unknown packet? So the cloud integration can be done on the firewalls, next gen firewall, where they can check the cloud, which keeps on updating. So every vendor will have their own cloud. Cisco has its own, Palo will have its own, and so on with the other things. And then they can take the decision whether to allow or deny.
So is this some kind of sandstorming facility?
Yes, exactly.
Okay.
Okay. Anything else that comes in your mind? We have
VPN?
already come again.
VPN?
VPN is a common feature. But let's say at least IPsec is a common feature. There are a lot of VPN which are supported in both iOS and firewalls.
The only difference would be remote access VPN, only supported.
Yes, exactly. The remote access VPN with any connect is something. Again, that you can do it on router as well, clientless and client. So all the other VPNs, say for example, remote access VPN or IPsec, right? Let's say Flex VPN. I'm talking from Cisco perspective. These are some Cisco VPNs. Get VPN, DM VPN. So this will be only supported sometime with Cisco vendors only, because they are Cisco proprietary. But whereas a generic one like let's say GRE or IPsec or all those things, most of the vendors will support it. Palo Alto supports, iOS will support, different type of firewalls will support it. So this is
What about
something.
what about the GUI and CLI command?
That will
SA
that will differ for every vendor. It will differ. Okay, no
like
matter.
like ASA can be GUI and CLI both, but routers and switches can't, right?
No, they are, because nowadays all this CAT iOS 8,000 and 9,000, they have a GUI facilities. Only the outdated ones like 3,000, 2,000, 1,000, they had GUI but very limited capabilities, more CLI. But nowadays all the new ones comes with a better graphical. Okay, so they will support API automation. They will support all regular SSH protocol automation via SSH. So that is something very, again, similar topic, I can say. Okay. Apart from this, I can say that firewall will have more features. You will have anti-spyware, anti-malware, antivirus, uh, IPS, IDS, all inbuilt, like a unified product. So if I just put down here, they will support intrusion prevention system, intrusion detection, anti-malware, antivirus, spywares. Okay, so these are some features that you will see on a next gen firewalls, definitely based on the license, because they need more license. The regular license will not work. So if you have this license, then your firewall can act as a unified product. That means one box, one firewall box, and you can deal with everything in this. You will have firewall properties, packet inspection. You can have the regular next gen capabilities. You can have IPS on that. You can have IDS. You can have the other, the other threat detection algorithms you can have in a single box. But if you go with the router scenario, since they don't support most of them, so you might have to use some other dependency. Okay, so there are some tools for other dependency, like WSA you can use, ESA you can use. So they will be like additional dependency, license, hardwares, or virtualization, whatever it is, it will be something like this. So packet will go there, a copy of packet can go, or they can be kept as an intermediate, then packets will be pushed down. So you have to do some alternatives in that. Whereas on a firewall, everything in a single piece. So any doubt so far? Are we good? Let's see what is this say. Packet inspection, access control, which is also called security policy in firewalls. We discussed about stateful inspection. We discussed about VPN, IDS, IPS. Yeah, so this is something which I have put in the document, but we could come up with 10 to 13 different points here. Okay, now coming to the basic understanding how this whole concept of firewalls comes into the network industry. So there was like something called Cisco PICs, which was a very traditional firewall, which was like only layer 3, layer 4, very, very, very much, limited support. So it was the first firewall from Cisco's portfolio, Cisco PICs. Then it got end of life 2008, and then is when the Cisco ASA comes into picture. So Cisco ASA started from 2005, and it went till something like 20, almost like 2020 or 18, I can say, when they announced it end of life or end of service. Because the reason is that more and more DOS DDoS attacks, the cyber security concerns, or the things, the challenges with hacking and all those started, and there was a need for the next gen. So there is when Cisco thought of getting into next generation. So what it did, instead of creating some solution from its own, it preferred to go with the acquisition of company called SourceFire. So Cisco purchased this company, and then they rebranded it with something called Firepowers. Then it was called as Fire Defense. A lot of naming conversion happened. Now all the Cisco products are called as this. Okay, it's called as Cisco Secure Firewalls. We don't use the word like source fire or firepower or fire threat defense FTD. Instead, they have a new name. This happened just a year back, almost a year back. So if you open the this network security portfolio from Cisco, you can see the different product line. So this is from the firepower perspective. So they have for a smaller business, this is for medium sized. Okay, this is for data centers. This is something for threat detection. These are for the high end data centers. Okay, hot swappable and all those things. So you can see them, they are all now labeled as secure firewalls. Even the new version of these FTD and FMC, they comes with this branding, the new iOS. The older one still would be showing you as FTD or the firepower based, but the new iOS comes with this naming. But in your exam, definitely you will not see this one, because in your CCI exam they go pretty on a lower versions, not on a very up to the market. So definitely this is only from your knowledge perspective, but from your exam perspective, you will be still dealing with something which is like a year back naming conversion. So we will be still doing a lab on this product itself. Okay, so this is something you will be hearing me coming with this firepower. So see, Cisco ASA was there for some 20 years. And then what Cisco did is they came up with a hardware which supports firepower. So all the new hardware used to be ASA and ASA capable of firepower. Then what happened was they wanted also a unified product for firepowers only. So then they started coming it with firepower product line. So from a very basic to very advanced one, so that it can have all the features in a single devices, like a unified solution. So till here, we used to call it as a regular ASA images, ASA iOS images. But then over here, we started getting this FX product, okay, which is a firepower images version. The packet flow for these devices are a bit different when compared to the packet flow for firepower, which consists of two engines. One is NOT and one is Lina. Okay, Lina is very similar to the ASA one. Okay, whatever happens in a ASA, that is what you will expect in this. Whereas NOT is bit different, which is more towards the next gen capable. So this is how now you have two packet flow. One is for ASA, one is for firepower. So we will see for ASA, might be we can talk about ASA packet flow, and for firepower, I'll take it in a next class. Okay. So to demonstrate this topic, we will just take a random example. Let's say this is a PC and the IP address is, let's say, 192.168 1.100, which let's say is connected to a router, and then router is connected to, let's say, ISP, and on other side the same approach, you have a router and then you have a PC. So this is 192.168. Let me give it 2 and 100. Okay. So initially what happens when the packet from this source wants to go to the destination. So let's say packet direction is this way. right? And yeah, let me say that this is ASA product, not router. Let's say it's a ASA product, and this is also a ASA product. So as soon as a packet reaches the interface, okay, so first thing I will say that ingress packet. The second thing that happens is a increment on the count of that interface counters. So it's like an increment on the counters. Okay, because as a packet comes in, there will be a +1 adding up. Then it will check for the connection table if it's a new packet or it's an existing packet. Let's assume that it's a if it's a new packet. So if it's a new packet, then next what it will do, it will see whether it's a valid TCP packet or not. So that means valid packet in the sense, is it starting with SYN or is it a different SYN ACK or ACK packet? If it is starting with SYN or SYN ACK without a SYN, then that packet is a spoofed packet and it has a capability to deny it there itself, considering that it's not a genuine packet, it's a spoof packet because it is expecting to start the communication from SYN packet. So that is a state table where the TCP will be checked, and then it will go to the NAT translation. If it is any sort of NAT, then it might do the untranslation first, because it cannot apply the policy based for a translated traffic. It has to untranslate, then it will see what is the policy talking about. So there comes the ACL then. So here it will say this is this so and so labeled. So to allow or deny happens here. In case you had some QoS properties, then there is a modular policy framework, which is MPF, and it will be based on MPF, whether QoS is to deny or approve. So let me say permit or deny, permit or deny. Let's say it's all getting permitted. Then it will move to the next gen features in case the firewall is being added with something called next gen. Like you can add IPS, you can add IDS on the ASA firewall, right? It's like extra hardware that you added. If you do that, then it will wait for this response. Otherwise, it will continue. Then comes the route checkup, route lookup to move out. Then it will see if it is having a NAT table to translate it, if the translation needs to be happened. Then it will go to the, let's say if there is a dedicated, this is an optional thing. If you have, let's say any threat detection or some modules that you have added. So that is why I added it as optional, because it's a additional hardware that you can put it on ASA. If not, it will pass on. Then it will go to the egress interface because it has to switch to next device. So here the L2 will be checked. Okay, and then the packet is transmitted. So this will happen in a regular ASA. There are like 13 to 14 steps that will happen. Any point of time, if you have set a deny rule, or you know that by default there is an implicit deny. So for any reason, if it is falling under implicit deny, packet life is down now. The packet life is expired at that point of time. So you should have that allow at least for each one of them. So you cannot keep it undefined. Or if you're not using, then don't use at all, but you cannot just configure some policies and keep it not permitted. If you do that, then the most of packets will go get dropped because of the deny statement. Okay, now another scenario, let's say if there was a VPN between them. So how does packet will know whether it should take this path or it should get into the VPN? Because because where is your NAT? Your NAT is over here, which is above. Okay, where is VPN? Did I not write VPN? Okay, here the VPN thing comes over here. Okay, somewhere, let's say, if it's a VPN traffic, let's say somewhere in this case, if it is a VPN traffic. So VPN is very down, right? And your NAT happens in the beginning. So there is chances that this guy 1.100, if he has to reach 2.100, more chances that it will take the normal regular path. Agree? Why? Because NAT is on a above level when compared to VPN. VPN comes on the later on stage. So the chances are that packet will always get via ISP. So in such scenario, what we do is we introduce something called identity NAT. It's a type of NAT which is kept above your regular NAT. So if you have a regular NAT, right? So because of this regular NAT, it was taking the ISP. But my concern is that I want to push that traffic inside VPN. So what I do in the identity VPN is I will say that source 192.168.1.100, destination, okay, let's say this port is the so and so. If the destination is what? 192.168, 2.100. This is how the identity NATs are written. When you can say if the destination is so and so. But in the case of regular NAT, which is kept below, because you know that NAT also goes in a line by line order. So the first execution happens identity NAT. And then comes your regular NAT. Okay, any pat or any dynamic thing. So in that, you only define in this format. You will say so inside, outside, and you will do the regular mapping. You will not define condition like destination. You will just say that it should be taking up a static public IP of this range, right? And the advantage here is that identity NAT is above the regular NAT. So what happens in this case, since we have put the condition and it is for this, now what happens is your VPN will be considered. Okay, the reason is that your NAT translation will be happening in such a way that it's an identity NAT. In terms of identity NAT, what happens is you will give the next translation to be the same IP. You're not changing the header of that now. The .100 you want to be .100 itself for this condition. You're not changing any header unlike you do in a regular. So by doing that, your NAT policy will be matched at this point because you know the policy matching that happens in VPN. Only an interesting traffic can get into. So that is when you will make your packet get into the VPNs by having your identity NAT. So you will see that in some scenario we go with identity NAT because the reason is your packet was taking over on the regular internet and you don't want a regular internet. You want that interesting traffic to get over. I can also show you that if you go to...
Is it the same thing as NAT exemption?
Yes, exactly. See here, when you do a packet tracer command, okay, right now we don't have any interface. So what I will do is I'll just configure one interface gig 0/0. Let's say name if outside, IP address, just a random IP I'm just giving to show you the different phases for packet capture. So let's say packet tracer input outside ICMP I want to check the packet direction. Okay, see right now okay, let me bring up that interface. So packet tracer input outside ICMP 1.1.1, 8 and 0 are the ICMP codes, type 8 and type 0. 2.2. See, this is how the packet will go from phase to phase. Right now, what happened is instantly it said that there is no access, there is no this one, there is no route available, so it is just denying it. So there are different type of phases that you happen to see in the ASA. Let me see if I can show you here. It's called as packet tracer command. It will be used for troubleshooting purpose. Not the packet tracer. There's a difference between. Yeah, this is the one. Okay, it would be very hard for you to see. So this is like phases. Phase 1, phase 2, phase 3, phase 4. But phases here doesn't mean that like your VPN phases. It's like step by step what it is going through. That is what we had written here. So in the CLI, you will see like phase 1, phase 2, phase 3. Basically, that is nothing but the step of the packet flow. It will go through 10, 14 different steps. That is what we have put. And that is what I gave you some example that if it is a regular NAT, it will take the precedence. If it is VPN traffic, then you have to make sure that you convert it into a identity NAT so that the traffic don't get still sent over on the ISP because of translation happening. Okay, so any question till here? If not, then I'll just take you guys to a very simple practical. The practical is that this is a test PC. Okay, this is a test PC, and he wants to reach or ping this interface of this particular. And intermediately, I have a ASA firewall. So we will see that how a firewall behaves. So for that R3, I'll just prepare my config here on a notepad. It's a router. So how do you prepare it? So let's say this is a ISP router. The interface, which is Ethernet 0/0, I'll say no shutdown. And I think it's a MLS switch. So I will go with this command. So the interface is capable of layer 3. Okay, so no switch port in the sense it's a layer 3 thing. I can give any IP addressing. Let's say I give it as 113.100.100 2 or whatever IP you want to give it. Okay, and a just default gateway. If anything comes to me, just send back to the ASA firewall. So this would be the IP on the IP on this ASA firewall on this thing. Because when I ping, the router should not drop the packet for the reply back. It should send back to ASA. Okay. Now for the ASA perspective, what will be the config? Almost the same. Like I'll say host name. Let's give it as a ASA firewall. I'll go inside the interface gig 0/0, no shutdown. Name if it's a outside interface zone. So by default, what will happen? The security level will be taken up as 0. If in case you want to do changes on that, you can write this command. or by default, the outside will be treated as 0 itself. Okay. Then the IP address, I'll give it as 113.100.1.255.255.0. The next interface, like let's say gig 0/1, no shutdown, name if inside, security level 100. 100 means green zone, 0 means red zone. IP address, let's say 192.168 1.2 or something. Okay, something of like this. And this is a Win PC, so that we can do some changes on the screen itself. So first, let me bring this configuration on the device. Go to the global configuration terminal. Okay, so you have copied whatever you prepared. We can just double check. So we have the interface configured. Do we have the default gateway? Yes, I can see pointing back to ASA. And we have the new host name configured. Then I'll go to ASA. You're already in the global configuration. So you can just copy paste the configs. So host name interface you configured, the second interface you configured. You can definitely add description if it is outside, etc., etc. It's the same thing that you have in the router as well. And from the Win PC, I'll open my Win PC. The password here is test123. You can also enable some captures, packet captures using Wireshark. Okay, and this Win PC, it may not have the needful IPs because they are all the brand new devices which we put just today in the lab, right, in front of you. So I'll just configure some IPs on that. So let me give an IP which we just gave it on the LAN side of ASA. So it was 192.168. And what was the IP? It was, I can give it 1.1 here. 192.168. 1.2 will be your ASA interface IP, which is acting as a gateway from this point of view. Okay, and DNS as of now not needed. You can just save this. You can save this. You can also better disable those inbuilt firewalls because some operating system they don't like such ping packet. They will be blocking your packet. So you can just turn off. This is a recommended step in your CCI lab as well, that you turn off anything such inbuilt firewalls on the PC, test PC. You can first just try to ping your own gateway, which is 192.1. What is the IP we gave it over here? 1.2, right? See, so you can reach that interface of ASA, but do you have a permit to reach that router, which is what? 113.100.100, and what is the IP of that? .2. Okay, so you can see that it's not reachable as of now. From the packet capture, you can see that from the packet capture, your router is trying to send the reply packet. Okay, it is able to get the packet and it is able to reply the packet. But from the ASA perspective, you're not able to get back the response. So how can I check on the ASA what is going on? I can check that if I apply some captures on that interface. So right now I will not have any captures here, but I can enable some captures. So I'll say capture. I will say that it's a outside interface. We can give it on a interface gig 0/0 real time interface. Let's say ICMP. Any to any I can give it. Okay, so you don't have any response here. Let me give it on an interface directly. Do you have a ping coming in? See, you don't see any response. Your firewall will say that on this interface you are receiving request and reply. Okay. What about on the interface inside? On the inside interface, what do you see? Okay. But it is still not having the response. The reason is if you see the connection table, there is no connection table built for this traffic. Okay. So what happens is here in the ASA firewall, by default, ICMP is not treated as a stateful packet. You can see that from the show running config.
No inspection for ICMP, right?
Yeah. So see here, ICMP is not added. So by default, ICMP will be not treated as a stateful connection. That is why what is happening, you're not getting the return traffic. Even though everything is good, it's not. So you have to add inspect ICMP inside this. And when you do that, you can see the response coming from the return from the ASA. So how you do that is you can get into this, then inside this, and just add inspect ICMP. So let's say policy map. What is the word here? It's basically a word, global policy, class inspection.
You misspelled the
Yes,
global.
Saga, you have a typo.
Okay. Okay, 1 second. Policy map, global policy, class inspection. Default, and then you can add inspect whatever you want to make it. So right now we want to make this ICMP traffic. And once you can check if this has been added or not. You can see that it is added now. And you can see the ping also has started. So we will just spend some time. What is this thing basically? So you should know that in the ASA, all the traffic from a higher level towards a lower level is by default allowed. That is inside to outside is allowed, but it was not working for me. The reason is I was trying with a ICMP traffic. If I would try with anything other than that, let's say TCP traffic or UDP traffic, then by default it says that it's allowed. By default, this traffic will execute without any additional modification. But if you are trying with ICMP traffic, then ASA has some default behavior of not making use of a stateful feature. So for that case, I enabled this particular few settings. So I said policy map, global policy, inspection, inspection default. This is basically the class. And then I said I want to include even ICMP. As soon as I made this, I got the response from the device. What is the second flow that can be possible? That is when you are receiving a traffic from outside to inside, outside to inside. These are all, implicit deny only. This will not work until you have ACLs. So until you have a permit statement, all your other traffic will be denied. And there is one more possibility, that is if you're talking between two similar zones or two similar levels, like 50 or 50 or 100 or 100. So by default, this was also not been permitted. Okay, by default, not allowed, or the packet will not be able to, but you can add some same security policies for that. Not a policy, like a CLI command. So if you put this CLI command, then this communication will also be able to. And remember, there's no need of any policies at this minute. You don't need any policy. If you just need them to talk to each other, so you can add this particular same security CLI command. Policy is needed for all outside to inside. For inside origin traffic, it is no need of any traffic. Only for ICMP, you have to do some changes. Same thing, you do that on the same levels. You have to put some command. But policies is to control the traffic, or let you know who to allow and whom not to allow. So the policies
Sagar,
are for second scenario.
Sagar,
Yeah.
for the third one, if you do not put that command, that same security CLI command, and you configure the policy, does the traffic allow?
No, it will not allow. Still, it will not allow. First comes the security policy, then the policy. Policy is optional in this scenario. To allow or to deny, you need a policy. But for communication, this command is needed.
So if you add this command, then by default, this communication will be allowed between same security zone.
Yes, exactly.
So then to control that one, if you have to configure that implicit deny policy within that interface, like any not allow, and on the about that one.
Yes, exactly. You have to come up with that ACL groups and ACL rules here.
Okay. Thank you.
Okay.
Hey, Sagar, for the first one, so by default, inside to outside is allowed, but you messed with the policy and added that inspect ICMP. In a regular production environment, we don't do that, right? We need to configure an ECL to allow that inbound.
No, by default,
reply.
By default in production as well, this will be done on the day one. This is a day one configuration. So most of the time this will be allowed, because if you want to test or something, this will be allowed. In the case of TCP and UDP, if you need more control, more granular control, then you can also come up with concept of bidirectional access, because you don't want every traffic that originated from this comes back without any security policies. So in that case, you can come up with implicit on that interface. So for written traffic, you can add a bidirectional rules. This is for TCP and UDP. For ICMP also, you can do the same thing. If you need a granular control, you can go with bidirectional. Otherwise, by default, this will be not allowed. It is only allowed for TCP and UDP only, the stateful feature. So to make this also a part of stateful, we added some changes in the settings. So it's a one-time configuration. This is done on the day one of your production, and then we just don't do all of these things.
Okay.
Okay, now just to wrap up, I'll do one last final thing here. So this is now working. I'll just show you how ACLs are put, or how do we, block this, because you might have done those things on router. I'll just show you in ASA also how do you write ACLs. So you first prepare a implicit deny rule for anything, any interface. First, you come up with a deny statement. This is because you want to put some control on the access list. You want to say that I have 10 rules, 10 permit rule, and the 11th one I want to keep it as a deny rule. So anything comes out of this 10 rule, you will see a hit count getting added up on that last line, which was an implicit deny. So you can just call this line with so which direction will I be adding? Because this is now happening in this direction. My packet is flowing in what direction? In this direction. See, my packet is going in this direction. So I will be adding my rules at this point, which is inside one. Okay. And on what direction the packet is hitting up on inside interface? It is hitting up in the ingress direction, inside one, because this will be the egress when the packet is leaving out, and this is when the packet is entering. It's in the in direction, because you should know from the direction point of view how the packet is traveling. So for this interface, packet is inwards, whereas in this, for this interface, packet is actually going out. Now, since you want to control this PC, you want to stop the usage of this PC going to this server or this user, you will be applying the rules at this point, right? So you will be applying at this point. So what you will do now with respective to ACL, where's my config? Yeah. So I will say that this is basically a word here. What name you want to give to your access list. Let's say I resemble it with my interface. It's in the in direction, right? So I will say that my last line, it could be anything. It could be 100, it could be 50. I'm just giving a bigger number because this will be the deny statement. So let's say I say line 50, extended, deny, ICMP, any, and log. This line I'm giving because I want to see how many such unauthorized packets are hitting on that interface, so that I can see some hit counts coming in. Also, while troubleshooting, it will help me with some counts. And top of this access list, in terms of sequence, you can have a permit statement. Let's say on the first line, you can say that extended permit ICMP, and you can define the one-to-one communication. So your communication was happening from 192, 168, 1 dot, what is this? The PC was 1.1, and it was going towards this interface, .2. So I'll copy this and I'll keep it here. Okay, so this is a permit statement, but I want to see the deny now. I want to deny this. So I'll say I'm going to deny this from this to this source, and on which interface are you going to add, and on which direction. That comes in the format of access group. So you will say access group. You just call it the same name. Okay, there is a typo here. Inside in, let's say access group inside in. Now there are two options normally, whether it's in or out. From our lab topology, it is a inwards direction, and on which interface you want to add it. So you want to add it on the inside interface, right? So this is what is now packet filtering. I will say that I don't want this guy to access it, but by default it is going through because of my stateful feature, because of its inside to outside. So it's moving on, but I can stop him. I put a control configuration T, and I'll paste it here. See, you can see that he has stopped, and you will see on the other side the access list hit counts. See, you can see the hit counts. It's a deny statement now. So if you check one more time, see the packets are increasing. Okay, so that means this guy is being asked to deny. Okay, so first my policy will be checked at this point. If the policy will say it is to deny, then it's denied. Now, if let's say that you wanted allow him, at the same time might be you have a deny statement as well. So there is a concept of that line sequence number. You can write a superior line. So let's say the same line with the better sequence number. If you make this one now, okay, forget about the previous line. Let's say if you make it as one and now you say it as permit, your previous one will get shifted to two and you will have a superior line with one. So that is what happens in a access list. If you write a new better line with a better line number and you put on top of an existing one, they get shifted downwards. So this will take up one, and whatever you have on that particular device as showing as one, it will become two, and the next line will take up the next line by it order. So what I will do, I'll just take this and come here, and I'll just paste it here.
The permit spelling is wrong.
Okay, sorry. Yeah. So let me take this and keep it here. Okay, now if you see the show access list, what happens? So your better line is up. It will take the precedence. Your deny is still lying, but it will not have any more hit counts. You can do one more trial. See, it is still 24 like previous, but your permit is being a better line. It is getting the hit count, and you should also see that ping start working now. So it is very similar config like you have in a router and switch, but with little bit of difference. Okay, so you will see that it was a basic lab. We just did from the perspective of the interface configuration, L3 interface configuration of a ASA firewall. Okay, so in the next class, I will show you some more ways like keeping this in a transparent mode or keeping this in a different way. Then we can also have the traffic originating from this direction, which we have not done in today's class, but traffic can also originate from outside to inside, right? In that, we definitely need this ACLs configured. Otherwise, by default, they're all getting denied here or dropped here.
In Sagar, there can be multiple ACL statements in the same line number, right?
Yes, you can have that also. You can have a group. You can make a line one and make all the different IPs inside that.
Okay.
Okay. And also, we don't keep this loosely held. We will also be talking about something called object group, which you don't see in a regular switch or a routers. This concept you will see only on the firewalls. So we will see what is object group and how we can make it in like look like a folder, a container, and within that container all the individual IPs. We don't keep ACLs like this because now ACLs are following a line order from top to bottom. The more lines you have, the more overhead you're actually giving it on the device. So more time it is to take from 1 to let's say 500 line it needs. Whereas if you give it in the object group, you're basically reducing the line counts. You can, reduce the line count, which will help the firewalls to look up the ACLs much more in a very lesser number of the ACLs line. That is the purpose of object group, and also from adding, removing of the individual IPs. This is more simpler. Okay. So any question from the technical thing? Because I am done from my side. You guys have any question from technical side? We will discuss. Otherwise, I will give it to my admission team who will talk about pricing and all the offers that's going on. So you can let me know. I'm here.
Sagar?
Yeah. Hi. Yeah, hi, Chris.
Can you share the UNL file for the lab somewhere?
This one? This one or the previous one? The main
I think
one?
the big that big one, that main one, yes.
Yeah, I will give you.
Thank you.
Yeah, if we can get the workbook and the UNL, that would be awesome, so we can follow it step by step on a daily basis, what we do here.
Yeah, definitely. This UNL I will give you, not a problem. So any other questions you have from technical? Because I would be passing it to my admission team now. So Sajid from my team will be taking care of that.
Do we need to purchase any reference book?
No, you don't have to. Everything will be discussed by Sajid. So those who guys have already enrolled, you guys can drop off because it will be just a admission process or management or pricing talk. You have already enrolled. So those guys who have enrolled, you can drop off. We are done for the day from technical thing. And those who guys want to enroll or who wants to know the pricing, etc., you guys can stay here.
Okay, thank you. Yeah, so I'll just see if you guys
You will
can
be
send us
you will be sharing the lab
information.
notes, right? The lab
Exactly.
details.
Yes. I will be sharing.
Yes.
Yeah.
So for
Please do so.
enrolled
Thank
people,
you.
I'll be sharing in the WhatsApp group.
All right,
Oh.
thank you. Bye.
Okay.